Well, no prize for guessing. This is another one from the same trade customer. So just make a note. Just make a note of that. So this is the non-DS one, and this was the one that seems to work better. I'm glad he sent the adapter with it. So the good thing about the 42, I mean, he said, what is it? Something like a 3.5 watt radio. It goes straight into a BNC, so there's no messing about. So we can run this straight off 13.8 volts, and we can get the output from the umbilical. However, once we take this apart, we'll have to do it from the BNC and faff about with crocodile clips. So let's see what we get out of it. Right, power on 13.8 volts. Connect it to the test set through a BNC adapter. So we're going to have a slight loss using an adapter. It's far better with BNC all the way. Right, here goes. Picture in picture on. And key it up. He wants it UK only. Okay. We have no power output. Perhaps if we go, perhaps it disables it once you go into the umbilical. That's it. 2.2 watts. One 108, 172. .491. So, how do we change channel? .1 watt. And 2.4 watts. Under the low power thing is when we're doing 2781 sets. I'm not that interested in what if it's got low power. I'm not going to start setting things which aren't. Is that high and low? It could be. If it's easy, I'll do it. Current consumption 1.1 amp. And if that is low power, it's 550 milliwatts. Deviation. Wallow. Sure, I'm not off tune, that's crummy. Wallow. Right. It's 0.5. frequency. Test set's only been on 5 minutes. Helps if I go into the right mode. 2779083. So it's slightly dropped, but it won't be that far out by the time the thing's warmed up. So we'll put something near into receive. We're not going out on a field test with this, we've done that before. We're just going to be doing an on the air test if we get to that. I think it's going to be working. I think it's just a retune. Set it a bit low for fairness, and hopefully we can plug the test instrument into the extension speaker socket, which I hope it has. Yep. So we'll look at the synod meter. So we've got 1 microvolt. .9. If it'll do 20, it will. 2.7. So I've got to take some of this with a pinch of salt because that lead is lossier than if we used the BNC. I don't think this squelch is going to be what I'd expect on a mobile set, but you never know. I'll tell you what it is. .250 microvolts. So it's not wishy-washy. And then at minimum, wrong button. .85. I don't know if the transmit meter on easy is fake or not, but it's reading 4 bars on transmit. And at S9, it's reading. How many pairs of glasses am I going to need to see that? It's reading 1, 2, 3. It's reading 5. So what is it needing to read more? It's about, I can't give you a set, it's about 10 millivolt. It's got a backlight, that works. Switches work, pots work, socket works, doesn't have PA, that's a good start. So we'll open it up, and I'll have to get the service notes. Turn the power supply off. Can't remember whether we take both of these out or not. I'd hate it to all fall apart inside if I've got the wrong screw. Oh, that tiny one there. And don't lose the spring out of the battery eject lever. I was hoping the belt clip wasn't going all the way through. Right, I'll disappear off and get the service notes, and then we'll see whether we can get somewhere with it. Right, I've been doing my homework. I printed this from the kind of makeshift service manual that I once found online, and I've made some notes from the circuit diagram which is here, made by Maxon. It does say it's 4 watts, and it's supposed to receive at 0.25 microvolts for 10 dB. So now comes the fun bit. We've got to power this up. I'm going to go to 12 volts, see if we get the same. So which is positive and which is negative is our next fun thing. So positive is the lower one. So we can put the negative there, out of the way, and the positive not out of the way on the battery clip, hopefully. Good. Now we're going to have to connect up to the VNC. Okay, so I now want to see if we're going to get something like we had before. So on channel 20 we were doing 2.2 watts. Let's go to the main meter. We've got absolutely nothing coming out from the BNC. So I was assuming there's some switching arrangement, but clearly it has a fault. So how do we get that sorted? So it looks like our BNC must be open circuit. Let's cut the power. I'm using this great big screwdriver. No, the great big screwdriver doesn't fit. And I thought this was just going to be a retune and test. We're going to have half a screw factory here soon. Our BNC adapter's faulty, not the radio. How can that be? The pin snapped off. Sorry to have accused you, radio. Pause the video while I find another. Okay, so with a brand new BNC adapter, which actually doesn't have a broken pin, let's connect that up. Well, while that heat sinks off, we'll be able to get to things easier. Transmit. Oh, we're not on, are we? Hey! We've got receive. So we'll concentrate on transmit first, like we do. So it's doing 2.5 watts on 12.5 volts. I think we'll tune it at that. Right, look at the notes. So L19, 12, 11 and 10. (19) 12, 11, 10. I wonder if 13 is adjustable. I'm gonna have to do this sideways on because I'm in danger. Actually, none of that's adjustable, is it? No, Mr. Tango, because it's under that screen. So we'll assume that to be preset correctly. So 12, 11 and 10. Is already peak. Is already peak. Tiny adjustment there. So power is RV5. I'd like something that fitted better, but I don't think we're going to get something that fits better. I don't think it's going to be that one. Nope. I think that's too big. I might be wrong. No, that's the one to use. So we've got a point at which it changes, and that's going to be the saturation point. So we're looking at 3 watts. It's in too precarious a position for me to go through the channels. So at this point, we'll say that's 3 watts. So I may as well put it on frequency now we've had enough time. It's a trimmer capacitor just there. Just go over to the frequency counter. It's actually spot on frequency now. so I'm not touching it. Now it's this pesky deviation, isn't it? We're going to have to read that on the test instrument behind me because I don't trust the one in front of me, which tells me it's 0.5. However, it might be right. Some days it is, some days it isn't. So let's go on to the Quartz Lock 282A behind me. Wallow. I've got to lift it to my mouth. Wallow. Say it's half on that as well. So if we look for the preset, it's RV4. RV4 is there. Wallow, wallow, wallow. And there we have it. Let's go back to the other test set. So why was that deliberately turned right down? Let's look on this test set now. See whether we've got a new improved reading. Have you ever been to a shop and had a new improved something or other, and in actual fact it's inferior to the previous one which you enjoyed? Wallow. That's saying it's light, it says it's 1.8, but it isn't, it's 2.2, so we can do that now. Good. So it's now 2.2 to 2.5. Out of interest, our transmit current is now 1.23 amps. So eat your batteries quicker. That's your trade-off. Now it does have an RF meter adjustment, so I want this to read 4 or something on its display when I key up. It's a full set of bars, I don't like that either. So we'll adjust that, and it should be, RF meter should be the lower one of those two. Now this is fun to adjust and look at the screen. Well, you know what? It's not going to make, doesn't make any difference where you put that. So I'll tell you what, we'll put it in low power. We've got 4 bars in low power. And then at least we can see where we're adjusting it, hopefully. So I've turned it to the lower portion, so it's showing 2 bars on low power. So now on high power, it's not showing a full set. So I think that's where we want it to be. Good. Let's look at a receiver. So once again we'll plug the test equipment into the speaker socket. We'll start by looking at the detector on the oscilloscope. So 100 microvolts, bit of volume. Let's check that detector out. And according to my notes, it should be this one. It was already spot on. You see, I'm not like a garage. It goes, oh, we had to adjust this, that, and the other. If I adjust it and it didn't need adjusting, I'd tell you it doesn't need adjusting. So we now need to drop the attenuator and go over to the synod meter. Because these figures are going to be better than when we were on the umbilical, so we will look at that. You see, now, without touching it, we're at 0.8 microvolts instead of 1 microvolt, just because we're on the BNC and we're not on the umbilical. So we need to go through our L4 and L3. No difference there. Difference here. And now we do the S meter. So S9 signal on the signal generator. Let's go down to the attenuator for that. So we've got 100 microvolts on there. And let's see what we're reading. We're still S5. That's the upper one of those two. The lower one was the transmit meter. The upper one is receive. If only we could just get the tool in. There we go. We've now got somewhere near S9. As I increase the signal, it will now go to plus 30. Good. So that leaves us with squelch, which was a bit tight, wasn't it? Let's put the squelch to full. There's 100 microvolts on the attenuator, so I need to drop off the squelch, which is RV2, until that opens. And that's 100 microvolts. So now we'll look at the sensitive end and see where it is. So squelch to threshold, signal generator back on. It's now coming in at 0.64. And now we'll look at the synod figures. We'll look at them again on the umbilical cord, because it's not that fair doing it like this. We're now at 0.56. For 10 dB, we're at 0.48. And the manufacturer says 0.25. But you don't know how they've come to that. So I'm in EMF mode. We put the signal generator to PD, which is easier to achieve. Now let's go to 10. And hey presto, to put 0.21. So they don't express how they're doing it. It's a bit like taking all the tyres and things out of the car and the washer fluid and only no petrol and so on, and then coming up with a fuel figure. So I like it on the hardest to achieve one, and that's where we always are. For 20 dB, it's now It's all to do with noise. It's not. It's 1.6. So that is now 100 microvolts calibrated. So that works. The internal speaker works. We'll put it back on. I'll try and put it back together. I'll see you in about half an hour when I've done so. Okay, so we're now back on the umbilical cord. I haven't finished putting. I haven't put all the screws in, but we've got enough now to look at some of the readings. So let's go back to the synod meter. So now we're on the umbilical cord and not the BNC. I'll show you the difference. So now we're at 0.96 microvolts. So, as you can see, we're losing it in the cord. So if ever you can use the BNC, especially with the BNC plug, you're going to get better range. But the convenience of this curly cord, of course, is another side of it. Let's go to transmit. So I'll stay on the 3 watt scale. La-di-da-di-da, there we go, 3 watt scale, go to that meter. So into the transmit, it is actually still 3 watts. So, but there may be a little difference with the BNC. It's the receive that it knocks for 6. And I will just look at the other channels since we did it first time round. Put the squelch on. So on channel 40 we've got 3.8 watts. 2.8 watts, what am I telling you? Put it in the wrong box. And on channel 1 we have got 3.85 watts. So put it as 3 watts. So there we go. And that's about what you expect. I'll just finish putting that together. In the meantime, we'll just put it on the aerial. I'll just see if there's any kind of people out there. And then we can wrap the video up. Just put it onto its own speaker. Swap that test gear one for the aerial, the real aerial. You know how some people just do not read what you write on videos. I'll always say how we're doing these tests. Did the on the air test for one of these, I don't know, some kind of hand portable with a BNC. And we're talking to Mr. Chippy like 6 miles away, and somebody comes up with, "You'll wreck the finals without an aerial." Well, how could it be working 6 miles when I've already explained it's on the umbilical cord? Really frustrating. None. Oops. 1-9 Roger. So some distant racket out there. I'll just see if our hand portable is here. Try not to rattle the microphones too much. Yes, it is. I just want to hear this transmit. We're on channel 20, are we? Change one of them. So talking to this one, testing 1 2, testing 1 2 3. That's this stupid Roger bleep, which I'll have to look at the instructions how to get rid of. And talk to this one. Testing 1 2 3 4 5 5 4 3 2 1 1 2 1 2. There you go. It's got audio. Right, so that wraps up the video for a Midland 42 we're doing on the air test. We haven't done the AM, we haven't done the 80 channel. We could have optimised it over 80 channels. The customer, like most of our customers, wants it on the UK 40. No interest whatsoever in the others. I expect AM works. I'm not here to test that. That's not what the remit is on this occasion. So thanks for watching.